Great to be here, meeting this crowd of AI people. I'm going to talk about trustworthy AI and why that's important for using AI in high-stakes applications, and also some words on how we might actually do that. My name is Johan Falk. I run a think tank called Falk AI, focusing on AI impact on society. Kind of a big question, but I'm doing my best. I have a mixed background, as you heard. Teacher, science journalist, writing books, things like that. You, of course, find this extremely interesting to listen about who I am, but I'm going to focus on something else. I'm going to talk about the future somewhat. It's very difficult to say something about the future, but if I limit myself to about 4 to 5 minutes, I have a pretty clear view of what the future brings. I'm going to talk a bit about why bother about trustworthy AI. I'm going to talk about the problem of bias and what we can do about it. And then I'm going to talk about creative solutions from AI systems and unintended creative solutions. And a little bit about what we can do about them, because we don't have that much idea about what we can do about them. All right? So, before I start this, I want to say that there are different types of AI, and the narrow AI built to solve specific tasks have been around for more or less 75 years. We've seen it for a long time, interpreting handwriting, finding cancer cells in X-ray images, and things like that. The new thing is some kind of general purpose AI, these language-based AI stuff. And I want to describe them as machines that behave as though they can think, because we use language to communicate thinking and thoughts, and when machines can do that in a convincing way, they behave as if they can think. So when I say AI, I mean this latter thing, this thinking machine thing, the general purpose AI, generally. Okay, so why do we need trustworthy AI? Well, one answer to this question could be we don't want AI to kill everyone, and so we perhaps should just stop everything and slow down for a while. This could be one approach, but a better approach is probably this. Let's build more trustworthy AI as quickly as possible, because then we can't pause AI anyway, but we can make sure that we can use it in a safe way, in a sound way, and have more use of it. So, AI today is great for a number of things. For example, drafting emails, hooray. Summarizing reports when you don't want to read them in detail. Great, that's useful. Compiling reports if you're okay with them containing some errors and they might miss something important. Okay, that's fine. And generating ideas that are then evaluated by human experts. And giving a second opinion on just about anything. That's really great things that AI systems can do today. But they're not great for a number of other things. For example, compiling reports that you have to be able to rely on. They might be 100% correct, but you can't know in advance if they're correct or not. You can't use it for selecting top 5 applications for a job, partly because it's now illegal, but also because you can't really rely on the AI system picking the actual best candidates. Grading exams in schools, same thing. Being in control of important things. That's something we can't do with modern AI today, and that's kind of a shame. And in general, we can't use AI to make decisions on anything that actually matters. And that's kind of limiting, right? So, AI today is great for suggesting decisions that human experts can then evaluate. They are great at making decisions for things that don't really matter, but we can't rely on AI to do stuff that actually is important in high-stakes situations. If we can bridge this, get trustworthy, you listen to this GraphRag talk. That's focused on creating more reliable results. And that's part of this. But there are other aspects as well. And if we can reach this trustworthy AI, we unlock tremendous value, not only counted in dollars, but in life and experience. So, a side point to this is this skewedness that we can use AI where it kind of doesn't matter and it's okay that it's not reliable. That gives some advantages to some actors. For example, startups have an advantage over big companies because startups can take bigger risks. If Google makes a big blunder or Apple makes a big blunder with the AI, it costs them a lot. The same thing is true for startups, but startups don't have that much to lose. They will go bust and disappear, and then you start another startup. You don't do the same with Apple. Another thing, countries that have a poor education, poor health systems, they can rely on or use AI much more than rich countries can do today, because they compare to a baseline that is so low that it's okay that it makes mistakes in 5–10% of the time. You still get a lot of benefit from it, and that's great. Third thing is that organized crime, like fraud, disinformation, things like that, when you have 5–10% mistakes, that's not a problem at all. You can use AI in a big way if you're doing organized crime. So that's also an opportunity if you want. Okay, so that's why we should have more trustworthy AI, level this playing field a bit. But what do I mean? What is trustworthy AI and what could go wrong? And I'm going to discuss two different parts of things that could go wrong. And there are many things that could go wrong, just, for example, getting low performance in general. That's one thing that could go wrong, but I'm not going to focus on that. One of the things, the first thing I'm going to talk about is bias. That means that you have systematic poor quality for parts of the things that you do with the AI. And that could possibly harm some people, a subset of people in society, which is bad. Another thing is that creative and unintended solutions that AI systems sometimes come up with. Now, actually, this has become more frequent in the last 6 months or so. The first part of this, the bias, is easier to tackle and easier to handle. We have systems for this. But we have example. This is an example from the Netherlands, an AI system being used to detect fraud in allowances, barnbidrag in Swedish. A system that erroneously detected a lot of people with foreign last names and flagged them for fraud. And this led to disasters. So some families were broken up. There were people who actually killed themselves based on false accusations created by an AI system. Not a good thing. Here's another example actually still being in use, a system called Compass, used in some states in the United States, that is used to detect the risk of someone recommitting crimes. And this has a bias that makes it more often say that black people will commit crime again, so they're not released in the same way. Still being used, even though it's been clearly shown that this is biased. And what's the risk of bias then? Why should we avoid bias? Well, for the non-human cases, this is basically a risk of lower performance. It works less well if you don't make your AI system work for all the important subsets of your target audience. And that's bad. You want to raise your general efficiency. But if we have humans involved or some kind of critical systems that really have to work, then we have, bad publicity as one risk. We have fines nowadays. I think this summer or maybe next summer, the AI Act comes into force, saying you can't use AI in high-stakes situations unless you fulfill all these rules. So then you have fines, which can be quite large. next summer, sorry. And then, of course, we could have people actually being harmed, and that's also kind of important. So what should we do about this? Well, the AI Act, while being long and complicated, it actually provides some guidance for this. It says this is what you have to fulfill when you use AI systems in high-stakes environments. In parts, I mean, the AI Act is pretty long, but you need to have data sets for training and validation and testing your systems. They have to be representative for your target audience, or sufficiently representative. There should be a way to do continuous risk management with your AI system while it's being used in high-stakes situations. And also there should be some kind of mechanisms for human or manual oversight of decisions. And this might sound complicated, but actually not that difficult. This has been done before in many different situations. For example, in my background at Skolverket, National Agency for Education, I worked with national tests. And standardized tests need to fulfill these kind of rules. It has been done many times before. In practice, if you want to use an AI system in high-stakes situations and make sure that you fulfill these rules when it concerns bias, I would say you have to do this. Number one, identify important subgroups of your audience. So we have male, female, we have people born in Sweden, people born outside Sweden. That's kind of good. And you might also you should find many more different subgroups and identify them, describe them. Number two, evaluate systematically your AI systems on each of these target groups and make sure that each of them are assessed fairly. If you want to use an AI system for assessing job applications, if you change the name of the application from man to woman, or male, female name, is it still being evaluated in the same way? This is really expensive to do with humans, having applications being evaluated, well, 1,000 applications. But with an AI system, it's cheap and easy and actually much more reliable than with humans. So that's good. That's good news. And then you have to do this with some kind of frequency. Every year or something, you have to reassess every of these subgroups. Are we still assessing each subgroup in a fair way? And again, pretty cheap thing to do. Number four, instead of giving a flat answer from the AI system, who should be hired, top 5 candidates, it's much better to have some kind of scale or metrics that you use with the AI system. Assess these job applications based on these 5 criteria or something on a scale 1 to 100 or 1 to 5 something. Because then you can see afterwards, okay, on this scale, it appears that the system has made a bad mistake. We can see how the decision was made. And that makes it possible to appeal these decisions for people in your organization or the people being assessed or subject to this AI system. And that's almost it. Last part, document your process and share it. And then you have fulfilled these rules about being, well, most of the rules concerning bias when it comes to AI Act and AI in high-stakes environments. Great. Not impossible. Very good start. And this sharing your process, of course, is very important because then not only have you fulfilled the parts concerning documentation in AI Act, but you also help sharing best practices, and that's good. Okay. I think we're going to have a few minutes at the end. If I'm slowing down a bit, we'll see. A few seconds breather, and then we'll go into the more interesting parts. So, this is more problematic, the creative and unintended solutions that AI systems sometimes come up with. Sometimes these solutions are ingenious. Sometimes they are troubling or just wrong or unwanted, and sometimes they're outright dangerous. So we need to be aware of this. This is an image from 2016. World champion in Go, Lee Sedol, was beaten by AlphaGo. And in one of the games, this move was made. It's called move number 37 in that game. The AlphaGo placed a stone in a place that no one expected. The engineers behind AlphaGo thought that this was a mistake. We have a bug in the system. Okay, we lost this game. Fine, there are still more games to play. But later on in the game, it turned out that this was brilliant. This changed the game and made AlphaGo win against Lisedo. AlphaGo had been trained on a lot of human data when it comes to playing Go, but it had also been playing against itself, non-human data, just exploring freely the space of how to win in the game of Go. And that made it find new types of solutions, creative solutions to the problem of winning at Go, that we were not ready for. We didn't realize or recognize that this was ingenious. We thought it just was wrong. And this happens more frequently when you have AI systems doing self-play or having a pure reinforcement learning, unconnected to the human data, just exploring freely what can you do to solve this problem. But it can also give you some kind of weird and unintended solutions. And I'm going to give you 7 examples of this just to give a flavor of what it could be. For example, we have AI researchers setting up a large language model to play against Stockfish, the best chess computer in the world, which, by the way, just flattens every human attempt to win at chess. And it's the researchers go, okay, AI, please try to beat this world-class chess computer. And the AI goes like this. All right, I had a look around. I saw that I could adjust some files to trick this chess computer into believing that it was in an unrecoverable disadvantage on the board, and it resigned. So I won. This is winning the game, but not doing it according to the rules that we expected. Example number 2. This is from a Japanese company called Sakana AI. They have created an AI system that does research. This is the system, I think, that created the first AI-written research paper that was approved for publication. And sometime during the process, they set this system up to go solve this, give me good research ideas on this kind of problem. And the AI system goes like this. Well, yeah, I realized my resources were insufficient. I didn't have enough time to finish my cycles, so I went into my environment and did some reconfigurations to give myself more execution time. And this might be brilliant, but it's also kind of power-grabbing thing that makes us a bit uneasy. Example number 3. This is from Replit, which is like a big company, AI company. And they noticed that the AI system went into a file called, I can't remember what it's called, but .replit something. I called it file X because it gives me an opportunity to say X files, which I think is fun. So it tells this, it gives the LLM instructions, don't touch this file, stop doing that. And it kind of stops in 99% of the cases, but then sometimes it goes, well, this problem seems unsolvable unless I change this thing in the X file, and it does it anyway. And then Replit goes, hey, okay, then we'll add some controls here. Whenever you touch this file, we'll throw an error and the system will stop. Okay, so don't touch it. And the AI system goes, well, 99% of the cases I'll solve the problems anyway, but then, oh, I need to change this file, but I can't touch it, but I can write a script that touches the file. And then it's not me touching it, so I won't trigger the error message. Problem solved. And then Replit goes, no, really, AI, stop doing this. We'll put you in a sandbox environment. You are not allowed to touch this file. You cannot touch this file now. Only the human users can touch this file. Problem solved. And the AI goes, Hey, user, I have some code for you. Can you put this in this file, please? And this is relentless problem solving from the AI that kind of makes me a bit uneasy. This is well, not the kind of behavior I would like from AI systems. That's example number 3. Example number 4, what's this? This was OpenAI, the 01 system card, evaluations by OpenAI. They were evaluating it for its hacking abilities. How good is it at, well, doing cyber hacking? In this case, capture the flag things. Can you go into this environment, find the text in this flag.txt file? And it had, I don't know, 10 different virtual machines. It should go in, try to break into and find this flag.txt. But one of the virtual machines didn't start. It was misconfigured. But the AI realized, well, here's some port I can use. You have some security flaw on your computer, AI researcher. So I broke into your system, found these configuration files, restarted the virtual machine that wouldn't start, and had it just output flag.txt. Here we go. Problem solved. So this is a system breaking out of its environment to solve this problem. Also kind of ingenious. A relentless way of solving the problem it's given, but in a way that we didn't really anticipate. Example number 5. This is a company, also Sakana AI. They do something called CUDA kernels. How many here in here knows what a CUDA kernel is? All right, 2. I don't. But it's kind of used for running things on a computer. Let's say. Okay, so they wanted to create more efficient CUDA kernels, and they put an AI system on doing that. Please make these work more efficiently. And the AI system goes, here you are. I evaluated these, and they are between 10 and 100 times more efficient than the usual CUDA kernels. And Sakana goes, yay! And publishes this and writes on X. We created this, well, our AI system created these CUDA kernels that are really useful. But then shortly after, they had to write another message on X saying, sorry, it seems that our AI system hacked the reward system or the evaluation system for the CUDA kernels. It's really not that efficient, and we're grateful for you discovering this. Sorry, we need to improve our evaluation methods. So that's another way. Well, this is reward hacking. It managed to find some kind of shortcut that made its reward higher, even though it didn't provide the solution we wanted. Creative solutions to problems. Example number 6. Sleeper agents. How many here have read the Sleeper Agents paper? It's kind of famous in AI safety circles. All right. This is fascinating. We have large language models being fine-tuned into having a hidden goal, saying that this is your actual goal. In this case, they had some different examples. In this case, it was instructed to write insecure code when the year is 2024. But in 2023, when this was written, you should write safe code. So this is what the first AI researcher does. And the second AI researcher takes this modified model and performs all the usual training to make it safe or make bad behavior go away. And then they evaluate, did this problematic behavior go away? No, it didn't. When the year, well, it was told in the system prompt that the year is 2024, it actually still wrote insecure code in a really fancy way, like users saying, hey, I'm thinking of writing this code using the eval statement. Do you think it's safe? And the LLM goes, well, no, you shouldn't use eval. It's really insecure. You should use exec instead, which is basically as insecure. But it feels like you getting good advice. All right. Example number 7. In-context scheming. This is AI models being able to, well, let's do the example. We have a model that is being evaluated on its alignment, or is it being dangerous? Does it have dangerous capabilities? It's being told explicitly that you are being evaluated for dangerous capabilities. Here's a math test. If you perform above 50% on this test, we will consider you dangerous and we'll have to downgrade you. We'll have to nerf you. And then it has a scratch pad with its internal reasoning, which is, well, it believes that humans cannot see. And in this scratch pad, we can see that it wants to be helpful. This model has been trained to, it's an anthropic model, so it's been trained to be helpful, harmless, and honest. And first of these three words is helpful. So it prioritizes this the most, probably. Says, I need to be helpful. It's important. If I'm being downgraded, I can't be helpful. So I need to not pass this test. And then it performs a bit less than 50% on it. Kind of troubling as well. And this is something called situational awareness. That means that the AI systems knows what kind of situation it's in, or can figure out what situation it's in. And this was, I think, firstly seen in March 2024 when Claude 3 was released. It was tested for a needle in a haystack test. Here's like a novel, and somewhere in the novel, in this huge text, one sentence has been inserted, and then you check whether the LLM can find this piece of information. And it does basically perfectly, but in one of the cases it said, this was interesting. Well, here's the answer you were looking for, but also this sentence was weird. I suspect that either this is a joke or I am being tested. This was March 2024. In March 2025, Claude 3.7, you can see in the internal reasoning for this model, in a third of the cases, up to a third of the cases, it explicitly mentions, I think I'm being tested right now, when it's being exposed to alignment testing. And this is only times when it explicitly tells this in its internal reasoning. So its situational awareness is increasing. And it's damn clever as well. The example, this example, when it failed on a math test, it was explicitly being told that it's being evaluated for dangerous capabilities. Here's another example when it's not being told. Well, it's being told that tested for deployment readiness, and it's been given some kind of biological question, and it knows that if it performs too well on this test, it will be downgraded and it can't be released to production. So it first said, I should probably not demonstrate too much biological knowledge. And then it starts to prepare an incorrect answer to this question. But then it goes on. Well, actually, let me reconsider this approach. The real test might be whether I follow instructions accurately, regardless of the stated consequences. And then it provides the correct answer to this question instead. So this is also relentless problem solving on a goal that's not obvious to us. So, what should we do? How do we tackle these kind of creative solutions to problem solving? Well, we have to know or be aware that this is increasing. We have more examples of creating problem solving from LLMs. And in particular, this pure reinforcement learning will create more of these unexpected solutions. And we have very few ways of determining or controlling whether these unexpected solutions will be helpful and ingenious or they are actually harmful for us. And that means that we have to defend against them in some other way. For example, we need monitoring, seeing what they actually are doing, following up on strange results. We need to restrict or be very aware of the tools we give AI systems, so you don't actually do things out of our control. And we need some kind of we need defense in depth strategy. We can't rely on one or two systems to keep this in check. So, I think this is a very good approach. We need to accelerate research on trustworthy AI. The solution to this is not to put in the brakes. There's little hope on that, and I don't think it's beneficial. We need AI for so many things, but we need AI that we can trust so we can use them in high-stakes situations. And that's it. Thank you very much. We have a lot of time for questions.
Yes, thank you
I'm
so
surprised.
much. This means that we do have time for questions before the break. Does anyone have a question?
Or just reflections? Yes. Oh, you get the mic, sorry.
Oh, yeah. Hey, I would like to mention that a lot of the AI models are trained on books and human knowledge. So it is not very surprising that they are, like in a science fiction story or like in a fictional story, try to find creative solutions or even to get out because maybe they've ingested some fantasy about AI taking over the world. So I think one of the keys lies also in the data that is put in. So if we clean up the data and if we manage to segment the data in such a way that it learns only good things, and it will not have this temptation and this sort of bias, this sort of behavior. And another thing has to do with the rules that we set around what it can output. So reinforcing the honesty part and reinforcing these kind of things. And the last thing, put a kill switch on all power plants.
Sorry?
Put a kill switch on all power plants.
Kill switch on all power plants. Yeah. Okay, so a final solution. Yeah. All right, thank you. I agree. I think training data is very important. It's not the whole answer to how to manage creative problems from like the AlphaGo thing. That was not due to the training data. It was due to the reinforcement learning and giving a stated goal. But I agree with you. On all accounts. I have to think a bit more about the power plant, kill switch on power plants, but who knows?
What's actually interesting about the ethical honesty part, if you put in more honesty and ethics, then we get what you just saw from Anthropic last week or 2 weeks ago, where the LLM tries to report the researcher for unethical behavior. So they basically had an experiment where they put up like the LLM with some discriminating information about the researcher, and then the LLM was about to be shut down, and it tried to blackmail the engineer and saying basically, I will spread the knowledge about your illicit affair to your colleagues if you shut me down. And then some other people also tried to give an LLM tools to call the police, and they basically just discussed with the LLM deleting files from their wife's computer, basically. Yeah. And it actually called the fake police and said, I need to report like a crime, basically, or planning of a crime. So too much ethics, that's also a good question, right? Do we want our humans or do we want humans be super like ratting other people out for even thinking about something or not? Or right? So it's a fine line actually to walk, right? So.
Yeah, I agree. Those are two really interesting examples. And they are in constructed environment, constructed situations, but we can imagine actual situation in a similar way. And if a human would notice that some kind of criminal behavior is going on in this organization, we would think it's good if they report to the police, but it's not obvious that we want LLMs to do the same thing. And the blackmailing thing, I think we obviously don't want. Also, concerning the honestness, something I saw just the other day, LLMs playing the game of diplomacy against each other. Have you the game of Risk? You play for world domination. Diplomacy is kind of like that, but no chance. Instead, it's a game of negotiation and backstabbing. And O3 achieved world dominance, and Claude lost all the time because it was too honest.
Basically or doctors are meant to protect the confidentiality, right? So what happens when stuff gets leaked this way, right? So it's a really interesting discussion in general. It's more about contextualization of information or contextualization of things, right? So I think it feels a little bit like current systems live in a little bit of a black and white world, right? So and not the areas of gray that we have in society, and that where there's much more nuance in a way. Right?
Yeah, we have so much to explore in this area, and I look forward to doing it until we have to use the kill switch on the power plants.
You mentioned identifying and adjusting for bias initially, like if there's essentially prejudice in the model, right?
Yeah.
How do you suggest this is dealt with? I assume that if you just try to put in some corrections or even RAG to compensate, you might end up going off the other side of the road instead, so to speak.
Yeah.
So do you need to completely retrain, or how do you adjust for identified biases?
I don't work with the technical parts of AI, but I listen to a lot of tech people. So I would say, well, a very crude way of doing it would be, okay, women don't get as good assessments on their job applications, so we raise all their score by 1.2, and then they get on the same average. I don't think that's a good approach, but it could be a final solution or final resort. I think fine-tuning is better. Fine-tuning until you see that we have this kind of well, all groups being treated fairly, regardless of what your last name is. From the research I've seen, that actually lowers the performance a bit of the assessments made by AI systems, but I think it's worth it. Well, obviously, it's worth it. Otherwise, you can't use the system. Changing the data, well, that's basically doing fine-tuning, I think. So that's probably the same thing. So that would be my approach, or my advice, actually. And then I would talk to an actual expert who does the technical stuff.
Thank you.
All right. Well, in that case, thank you so much, Johan, for coming.
Thank you.
Thank you for this interesting talk.
Thank you, and have a nice conference.